Hey Geometry, one last example for section 6.3 dealing with parallelograms. But this is a big one, takes a little while, so it gets its own video. Graph quadrilateral KLM, and it's already been done, but you basically can't see it, so I'll get it in there. With vertices K, and so this is the first coordinate, this is K, and that is at the coordinates 2, 3. I'm going to write it on here just because it is such a mess. Sorry about the quality of the copy. 2, 3. So that's K. L over there at 8, 4. And yeah, this is the x-axis, by the way. I'm trying to move there. Sorry, that's the y-axis. This is the x-axis. So 2 over 3 up, 8 over 4 up, and then this parallelogram continues on down to here. Bolden this guy up a little bit. And so then we've got M at 7, -2, so that is M, and that is at coordinate 7, -2. And then this one is N, and that is at coordinates 1, -3. That should be a -3. It is scratched in up there, but that should be a -3. 1, -3. All right, so we've got our parallelogram. Actually, determine whether the quadrilateral is a parallelogram. Justify your answer using the slope formula. So we're just going to prove this. There's a few ways we could prove this. All right, I could actually use distance formula and show that opposite sides are the same distance. That would work. Measure of that angle, we're not quite there yet, though it is doable. And I could show that like diagonals bisect each other. I could find the intersection of the two lines that go through those points and and then find these distances, and like that's not the way that we want to necessarily do that. But actually, we could just think through that the midpoint is the same for both of those. And if that's true, then we know that it is a parallelogram. But they want us to do this with slopes. So we're actually just going to use the definition of a parallelogram. I want to show that this line is parallel to that line. And using slopes, I can just show that they have the same slope. If we know that they have the same slope, then they are parallel. So I'm going to just go ahead and start going through this. I'm going to do the slope of I'll do this first. Kn or nk, slope of nk, and I'm just gonna kind of count it out. You can do difference of x minus difference of y. That's fine. You could do y2 minus y1 over x2 minus x1. I'm just gonna count up my rise over run. So we're going up. Well, maybe I should just do the difference in x's. We're going up from -3 to +3. So 3, I will, whatever. It's such a mess to count it out. I guess I will go ahead and write these out. So we're doing 3 minus -3. Our rise is 6. Our run is 2 minus 1. All right, so we rise 6 and we run 1. So a slope of 6. So that's that slope. And then I'm going to go ahead and skip right across to it, to the slope of ML. All right, and our rise, we're going from -2 to 4, so that's a rise of 6, or you could say 4 minus -2 for y2 minus y1 over x2 minus x1 over 8 minus 7. So we run 1 across. Rise 6, run 1, and you get a slope of 6. We've just shown that these are parallel. All right, get a little parallel triangle on there. Parallel lines, halfway there. So then we're going to repeat this process for the slope of KL. All right, that slope, that rise over run, so y2 minus y1, so this is like 4 minus 3. Our rise is 1, we go up 1, and then we're going over 6, 8 minus 2. So our rise is 1 over I do that right? Yeah, 1/6. So rise once, run 6. And so there's our 1/6 slope. And then we just got to get down here and see if this is the same. The slope of NM is our rise -2 minus -3. So +3 is a +1 in the numerator. And then our denominator, our horizontal run, 7 minus 1. our run is 6. So those slopes are the same. So basically these are the same, these are the same, right? And that's how we know they're parallel. Same slopes are parallel, so I'm going to do a little triangle here, and I actually have to do 2 triangles, right? Since I've used 1 triangle for that. I don't want to say these are, you know, parallel to each other. So the opposite sides are parallel, and so then we know that this is a parallelogram. So I guess I should answer the question. Yes, it is a quadrilateral. Both opposite sides are parallel.